Welcome to 3 Steps to Sketch on Function Transformations. In this video, we are going to look at a transformation of the square root function. So we will be looking at y equals 3 times the square root of negative x minus 1. And to do this, we will use the table method. All right, so here's our reminder of what we're graphing, and here is our setup. So we have our 3 steps to sketch outline, we have a table, and a grid. So let's go ahead and identify our parent function before we jump in. And like we said, this is a transformation of the square root function. So that's y equals the square root of x. Okay, so that's what we'll be transforming. And now let's go to step 1 and analyze our transformations. So the first thing to notice is that we have multiple horizontal transformations. Okay, we know these affect the x coordinates, and we know in this function, these are the transformations that appear underneath the radical with the x. So we're specifically looking right here. Okay, so you can see we have both a shift and a reflection, and when we're working with horizontal transformations, we want to think solving order. And that's how we'll handle them. That's how we'll order these transformations. So just to do a little scratch work, take those horizontal transformations, set them equal to 0, and that'll help you make sure that your order of applying these transformations is correct. So if we were to solve this little mini equation, the first thing we would want to do is add 1 to both sides. So that's what we also are doing as our first horizontal transformation. We'll add 1 to our x's, which moves it right 1. X's plus 1. Okay, so then our second one, of course, is the only one left. But let's look at that equation. We'd have negative x equals 1, and so we would be dividing by negative 1, or really just changing the signs of all our x's. We know a negative reflects our graph over an axis, so in this case, we're reflecting over the y-axis, or horizontally. So our second horizontal transformation, for shorthand, we'll just write capital R, Y, meaning a reflection over the y-axis, or we're taking all of our x's and we're making them negative. All right, so those are our horizontal transformations. Now let's look at our vertical transformation, and that's the 3 out front. Okay, so remember, vertical transformations affect the y coordinates, and what you see is what you do. If you have multiple, you would use PEMDAS order. Here we just have the 1. We see that 3 times the square root, and so that means we're going to multiply all our y's by 3. So that will stretch our graph by a factor of 3. Okay, so that's just y's times 3. All right, so those are our transformations. We are ready to move on to step 2 and get our table going and apply these transformations. So before we do that, we want to remember our points for our parent function, the square root of x. So that's the shooting star graph that's really mostly in the first quadrant. So we know that one starts at the origin at 0, 0. It has a point of 1, 1 because the square root of 1 is 1, and a point at 4, 2 because the square root of 4 is 2. All right, so now that we have our parent points, we're ready to apply these transformations, and we'll go ahead and start with the horizontal or x transformations. All right, so we'll create 2 columns. In the first column, we will move everything to the right 1 or add 1. So simple enough. And then after that, we're going to divide by negative 1 or just make all of these values negative. So that's going to cause our reflection over the y-axis. Okay, so those are our 2 horizontal transformations taken care of. And now we can do our vertical transformation, which is to multiply all the y values by 3. So we have 0, 3, and 6. All right, easy enough. All our transformations are applied. And remember, with the table method, your final outer columns are going to give you your final points. So our final x's are here, and our final y's are here. Okay, so now we can do step 3, plot the points and sketch the graph. And remember, we're expecting a reflected shooting star graph. So the original graph looked something like that, sketched up by the parent function equation. So let's plot our points. We have -1, 0, -2, 3, and -5, 6. We'll kind of extend our graph here. So we know that it should follow just like that. All right, so that was sketching a transformation of the square root of x graph using a table method.